Graph or modeling with trigonometric functions. C1 is a communication thing which I am going to share with you. A quick note on periodic sinusoidal function. Now, before getting into details of sketching graphs or writing equations for the graph or picking up some real life situations and modeling them, with a trigonometric function, let's try to understand what is a periodic function and how can we really use it. So let's try to understand a periodic function first, correct? So let me just sketch here a simple periodic function, right? And I'll just make a wave like this here. So we have this wave and like this it goes, right? So this wave normally we say is a sinusoidal wave, right? Sinusoidal waves normally start with zero value, correct? But any wave like this is referred to as sinusoidal wave. If it starts here, then we say it is shifted. There's a phase shift, but it's the same wave, right? So that is our sinusoidal wave. And when we are trying to say a trigonometric function, we are always referring to this particular wave, right? You will see one thing, that it has kind of a line of symmetry, and that we call as the axis of this wave. So let me sketch that line of symmetry for this wave. It's let's say this, right? You see, when we draw this wave, then we see that it goes above this and below this to the same extent. So that is kind of line of symmetry. Now, generally, we represent our wave in a kind of equation. Let me write a sign, general function, which will represent this kind of a wave. We say f of x, function f of x is equals to a times sine within bracket k x minus p plus q. Now, this is the equation which we are going to deal in this section. Almost in every problem we deal with, it is this equation which we are working with, correct? So let's try to understand this equation. Here, the term A is for the amplitude of our sinusoidal function, right? Amplitude means how far it can go from its mean position. So you can think this as its mean position. So that distance from here to here, that distance is A for us, correct? So this is A for us. Now, Q is when we draw this wave on coordinate axis, let us say, right? If we draw it on a coordinate axis, let's say this is our coordinate axis. Okay, let me just first make it here itself. And let me say this is our coordinate axis somewhere here. Correct. Now, in a coordinate axis, this will be our x and that will be our y, correct? And y is f of x, this function, and x is this variable, and that is how our wave is. So q means that how much has this axis gone above the horizontal axis. That is what q is. So this point is q for us, right? So that is what it is a vertical translation of your wave, right? Above this axis. Normally, if we say a normal function which has not got transformed, or we may say a parent function which is sinusoidal in nature, then that will be here on this axis, right? The axis of symmetry will be exactly the x-axis, correct? Now you can see that this wave has no restrictions in the domain, right? Its domain is all real numbers. So that's the main thing, right? Domain of your sinusoidal functions is x belongs to real numbers, correct? But however, range is restricted. Now range is what? Range is from maximum to minimum of your transformed function, right? As you can see here, maximum it could vary, it could go a units up and it could go a units down. So let me say this is a units down from the mean position of q, correct? From the mean position of q. That means the maximum value it can have is q plus a, and the minimum value which it can have is q minus a, right? And therefore we can say that the range of our function f of x is actually between these two limits, right? It is more than q minus a, so I'll write q minus a here, but it is less than q plus a, less than equal to, correct? So that is how the range of the function is, right? So I think you understand a couple of things here. Now a is referred to as an amplitude of the wave, right? So we'll introduce you to amplitude. So amplitude is, now you can understand this a, how far the wave can go from the mean position, right? So if we have a Ferris wheel, for example, right? Let's think there's a wheel here, right? Ferris wheel. That's a practical situation which I'm taking, right? And people are getting into the wheel from this position. Let us, in this particular case, if it's going up, let's say they're getting up from this position, right? And the wheel is moving counterclockwise. Movement counterclockwise in trigonometry is considered positive angle, right? So you can see as you move counterclockwise, the height of the person changes, correct? And that is kind of reflected here. And as you go on the top, the person is here, and as you go there, with time, this is time on this axis, right? And once you come at the bottom, then you're here, correct? So like this. So wave can model, you can see this wave can model this kind of a situation. Perfect. So that is how we are using this wave for modeling. And in this particular example, the amplitude really is the radius of your wheel. Is it okay? From here, that is the amplitude. And Q is how much distance the center of the wheel is from the earth, from the ground, right? That is what it is. Well, and that is the position which is the lowest position, right? So you can see amplitude is actually equals to A from this equation, right? We also learned that we can actually find maximum and minimum using Q and A. If you add them up, you get the maximum, right? So let me write down that part also, which we just now learned. That is, maximum is equals to Q plus A, and minimum is equals to Q minus A, correct? At times, you'll find that maximum and minimum is given to us. For example, you may say, well, the temperature is varying and the maximum temperature in this region is around 40 degrees, but the minimum is around -2, right? So you have to write or model this situation. In that case, you know maximum and minimum. From maximum and minimum, we can find amplitude and the vertical shift, right? If you add them, then A and A gets cancelled and you get divided by 2, you get Q, right? So Q could be written as maximum plus minimum divided by 2. So you can see Q is actually the average value, right in the center, the average value, correct? So that is also a way of checking on it, correct? Now, A amplitude also you can find from here. How will you find amplitude? Amplitude A could be subtract them, right? So you can write, if you want to find A, then amplitude equals to maximum minus minimum divided by 2. You will get A, right? So this is the way you can work with amplitude, the vertical shift, maximum value and minimum value. So all these things are related. Now let's talk about time period and this value K, okay? Now in one full circle, if you go one full circle gives you one full wave, right? So the time taken to move one full circle is actually the time period. So that is how you get time period. And therefore, this distance from here to here, that is time period T, right? This is the time period. We say time period T, we'll call it, let's say this time is, let us say T, and that is called time period T. So time it takes to move one full cycle is the time period, right? But the K value is, now if you make one full rotation, then you do 360 degrees, right? So the K value is equals to 360 degrees divided by the time period, correct? So that is how you find the K value in your equation. If K is given to you, then you know, well, if K is given to you, then say time period is equals to 360 degrees divided by K, and they are related, right? Inversely proportional to one another with a constant factor of 360 degrees. That is the relation between k and time period. Now, many times in situations, you are given two maximum points, right? So two maximum points separated by, let us say, you hear some siren and then you hear maximum voice or the frequency 5 times in 60 seconds, let us say. In that case, you can find the time period by knowing time between two maximum. So time period is time between two maximum. It is also time period between two minimums, right? Two similar positions. These are periodic. Periodic means they repeat after a fixed period, and that period is the time period. So that is how we have to look into these situations. Well, at times you may get only a maximum and minimum position. Then the time period is twice this length, because this is always half the time period, correct? So these are different ways in which you can see or understand your equation and relate it with the graph or to a situation, correct? Now one thing more which I want to emphasize is on phase shift. When you write a sine wave, then sine waves start with zero value, right? Or the value at the mean position. They always start from the mean position, and that is considered to be a phase shift of 0. So we say no phase shift. It is sine theta. Sine 0 is 0. That's what we say, right? Now as if y-axis, it doesn't start from here, if it starts somewhere else, right? For example, if my wave actually starts earlier, let us say, then we say, well, this phase shift is the wave started earlier is minus those many units, right? And normally we try to give those units in terms of time period. That is also there, correct? So it is kind of important to understand it. For a sine wave, you will notice that the maximum is quarter of a period. Do you see that? This is half of a time period, and maximum comes at quarter of the time period. That is, this point is always at t over 4, quarter. This 0 is at t over 2. Minimum is at 3t over 4, right? Third quarter. And the fourth quarter, the wave completes, right? So if you divide one wave in 4 quarters, so in the first quarter, it reaches the maximum, t over 4. In the second, it comes back to its normal position. This is the normal position. And third, it goes to the lowest point, the minimum. And the fourth, it comes back to its normal position. And this position is same as that, because in both the cases, you are rising. Do you see that rising? So that is why they are exactly same. And we say that one cycle has been completed. So I hope now you understand all these things, and this is going to help you in modeling as well in sketching graphs. Well, share your comments with me if there are any other things to understand. I would like to elaborate on that, because this is kind of foundation for this unit. Thank you.